In this chapter, two terms are important: reduction. The first one is reduction. Reduction is a half reaction. Oxidation is another half reaction. So from reduction RED and from oxidation OX, these two combine, and final we get a complete reaction is redox. So if we analyze redox, we get two terms: reduction and oxidation. The definition of oxidation and reduction, for this you want to use these four terms: electrons, hydrogen, oxygen, and oxidation number. Hydrogen and oxygen was the old concept, the latest contributing electron number, but most cases we use oxidation number. Oxidation is a half reaction where electron lost, electron losing, hydrogen losing, oxygen gaining, and oxidation number increases. What is oxidation number? I'll discuss after a few moments. Then reduction is the gaining, hydrogen gaining, oxygen losing, and oxidation number decreases. So the vital point is here oxidation number. Let's see oxidation number. For oxidation number, we have to know some rules. I want to discuss here four important rules you have to know to find out the oxidation number of any element. The first rule is oxidation number at free condition equal to 0. Because number of proton and electron equal, number of positive charge, negative charge equal, so they are neutral. Potassium is 0, oxygen 0, chlorine 0, iron 0. Oxidation number of any ion is equal to charge of the ion. If you consider here potassium is +1, oxide -2, and chloride -1. Oxidation number of any element equal to the valency or when they make compound. If you see here potassium oxide is a compound. In this compound potassium is +1, valency is +1, so oxidation number +1. Similarly for oxygen -2, oxidation number of a compound equal to 0. So potassium oxide is the compound, so total is equal to 0. How it is coming 0? Potassium is +1 multiplied by 2, +2, oxygen -2, so +2 -2, that is 0. These rules are really important to find the oxidation number. So oxidation number calculation practice. The first example, potassium manganate. We know the oxidation number of potassium, we know the valency of potassium, we know the valency of oxygen. So potassium is +1, oxygen -2, total equal to 0. We need the rules 3 and 4. So here manganese is unknown, it is X. This is simple maths, you can calculate easily, and the oxidation state is equal to +7. Another example, sodium thiosulfate. We have to find the oxidation number of sulfur. We know the valency of sodium, we know the valency of oxygen. Sodium is +1, oxygen is -2, and total equal to 0. We are using the same rules 3 and rules 4. From here X is unknown, sulfur we have to find out. So from simple maths, X is equal to +2. Similar practices you can practice to find out the oxidation number of underlined element. After finding or during finding, if you have any confusion, you can write in the comment below. You can get the answer instantly. Oxidized and reduced substance. In this reaction, carbon plus oxygen, carbon dioxide, carbon is oxidized because oxidation number increases. In the left side carbon 0 and the right side +4. The same reaction, oxygen is reduced. Oxidation number in the left side of oxygen 0 and the right side -2. Oxidizing and reducing agent. Carbon is here reducing agent because oxidation number increases, and oxygen is reduced or oxidizing agent. Oxidation number decreases from 0 to -2. The substance which is reduced, that is also oxidizing agent because decreased the oxidation number. The substance reduced, oxidation number decreases. This is also called them oxidizing agent or oxidant. The substance which is oxidized, oxidation number increases, that is also called reducing agent or reductant. List of oxidizing agent and reducing agent. I have given the list of oxidizing agent. The reduced potassium dichromate, that is orange color, potassium manganate is purple color. The non-metals, chlorine, bromine. Then the higher valency of iron 2, Fe2O3, ferric oxide, iron 3 oxide. These are the oxidizing agent. Reducing agent, all the metals are reducing as exception. Some non-metals are reducing agent like carbon and hydrogen. Potassium iodide is colorless, potassium bromide colorless. These are reducing agent. Iron 2 oxide is the reducing agent. One example, in this reaction in this reaction, we have to find the oxidizing agent and reducing agent. The first duty, we have to find out oxidation number. Oxidation number of Fe plus 3, carbon monoxide plus 2, iron is 0, carbon dioxide, carbon is plus 4. From here, Fe2O3 is the oxidizing agent. Oxidation number decreases. CO is the reducing agent because oxidation number increases. Another example, H2S plus SO2, we get sulfur plus water. In this case, we have to find out oxidizing agent and reducing agent. So first, we have to calculate the oxidation number of sulfur, not hydrogen or oxygen. So by -2 plus 4 and 0. In this reaction, the sulfur dioxide to sulfur dioxide is the oxidizing agent. Oxidation number decreases. And the similar way, H2S is the reducing agent. Oxidation number increases from -2 to 0. Test of oxidizing agent. If we want to test a substance is whether oxidizing agent or reducing agent, for that one we have to use the non-reducing agent. Non-reducing agent react with X, so X must be oxidizing agent, because oxidizing agent plus reducing agent reaction happens, but oxidizing agent plus oxidizing agent no reaction. Another test of reducing agent. For that one we need the non-oxidizing agent. Non-oxidizing agent we use K2Ca2O7 is orange color. We're using Y and color changes, reaction happens. So since K2Ca2O7 is the oxidizing agent, so Y must be reducing agent. In this topic, do you have any specific question? You can write in the comment below. I think you will get the correct answer from this video. If you have learned anything, you can subscribe this channel and share with your friends. Thank you very much.